Dear friends, in this video, we will discuss the conceptual framework of T-distribution. T-distribution has in fact revolutionized the hypothesis testing procedure when the standard deviation of the population is unknown and the specialty of the T-distribution is that it can deal with small sample size. It is not necessary to assume large sample when you use the T-distribution. And it's a breakthrough in the history of statistical hypothesis. Let us now look at the important hallmarks of T-distribution. The shape of the T-distribution with 4 degrees of freedom, you can see now in the screen, where T is defined as x bar minus mu divided by S by root n, where S is the square root of this expression, S squared, which is sigma x minus x bar whole square divided by n minus 1. And this n minus 1 in the denominator, in the case of T-distribution, is the degrees of freedom for the T-distribution. In other words, the p-value of the T-distribution depends upon the degrees of freedom. The shape of the T-distribution will also change according to the degrees of freedom. Let's now look at some of the important features. Students' T-distribution was discovered by Gossett in the year 1908. In fact, the scientist nicknamed himself as student and published this paper. It was later perfected by the illustrious Ronald Fisher in the year 1926. This distribution, as I told earlier, has revolutionized hypothesis testing for small samples with unknown standard deviation. Of course, T-distribution requires the assumption that the samples are drawn from a normally distributed population. In large samples, it's practically normal with mu equal to 0 and sigma is equal to 1. When we say large sample, the acceptable threshold level is n greater than or equal to 30. We assume the central limit theorem, and therefore practically when the sample size is more than or equal to 30, the mean is equal to 0 and standard deviation is equal to 1. It's practically a normal distribution. The T-distribution assumes the normal distribution, and therefore we don't have to worry. The specialty is that scientists sometimes deal with experiments which involves small sample size, and therefore we need to have a statistic to test the hypothesis about the population parameter mu. So T-distribution is a landmark breakthrough in the history of statistical hypothesis. You can, of course, use it for large sample, but in large sample anyway, the central limit theorem applies. The shape of the T-distribution, when you look at it, it's more peaked than the normal distribution. More peaked is also called, the shape is leptokurtic. The tails of the T-distributions are larger than the normal distribution. T-distribution is also symmetrical like the normal distribution about its mean value. The p-value associated with T-distribution depends upon the degrees of freedom. And if you look at the shape of this t distribution, it is more peaked. And I have marked here the p-value for the positive ordinate when t is equal to 2.776, which is 2.5%, and the p-value for the negative ordinate minus 2.776 is 2.5%, and this part is 95%. The shaded area together represents 5% of the area of the curve. So when you want to calculate the p-value, the probability t less than a specified value or greater than a specified value, you need to look at the degrees of freedom also. And this is very important. And we have a lot of applications, both one population hypothesis testing as well as bivariate case. We will see an example very soon. And I conclude this video giving you a picture that t distribution is an extremely important distribution in the application of hypothesis testing for decision making. Thank you very much. We will see you soon.